Today we're going to be going over how to evaluate inequalities, but before we do that, let's review some of the language that we use with inequalities. Okay, 54 is less than x. We do 54, write it right below like we've done in the past, and x, and then less than. So I have two options, these two signs. I know from what I remember that the less than sign looks like an L, so I'm going to put that over here. 54 is less than x. That would be the correct answer for this one. All right, for the next one, x is greater than or equal to 9. I'm going to bring down x, I'm going to bring down 9, and then I have greater than or equal to. So I have two possible signs here. I can have the greater than or the less than or equal to signs. So this looks like an L, so that's the less than or equal to. That's not what we have up here. The greater than we can make into a G to help us, greater than or equal to. So we would want to do the greater than sign. So greater than or equal to. So x is greater than or equal to 9. Those both check out. All right, now we're going to choose the variable that makes the equation true. So the variable answers, we have possibilities of 2, 3, 4, and 1. So I'm going to plug in each of them. All right, 4 times 2 plus 6. 4 times 2 is 8. 8 plus 6, I'm following my order of operations. 8 plus 6 is 14. All right, let's do another one. Plugging in 3 for x. 4 times 3 plus 6. 4 times 3 is 12. 12 plus 6 is 18. That's a possible answer. I'm going to circle it for now, but we should always check all of them. 4 times 4 plus 6. 4 times 4 is 16 plus 6, which is 22. And the last one, 4 times 1 plus 6. 4 times 1 is 4. 4 plus 6 is 10. Our answer is B, 3. 3 is what would make this equation true. Let's do the one down here. Here we have y minus 7 equals 8, starting by plugging them in. 12 minus 7 equals, 12 minus 7 is 5. That is not an answer. All right, 9 minus 7. 9 minus 7 is 2. That's not the correct answer because it doesn't equal 8. 15 minus 7 equals 8. That does true. So 15 plugged in for y would give me an answer of 8, but let's try the last one. 8 minus 7 equals 1. That would not be true either. All right, moving on. All right, we're going to choose the value that makes the inequality true. So here we have 10 times 1/2 has to be greater than 10. So I'm going to write greater than here underneath. So the number doesn't have to be equal to 10, it just has to be bigger than 10. All right, 10 times 1/2 is the same thing as dividing 10 into 2, and that is equal to 5. That is smaller than 10, so that's not an answer. 20 times 1/2 is like dividing 20 into 2, which is equal to 10. 10 is not greater than 10. If it was greater than or equal to here, then it would work, but since it doesn't have that, it is not a possibility. All right, 30 divided, oh nope, sorry, that's me just thinking ahead. 30 times 1/2, I'm plugging in 30 for v, is equal to 15. That is a possible answer. 30 would possibly work. Let's try the next one. 40 times 1/2 equals 20. 20 is greater than 10, so the answer would be both C and D. For inequalities, there's always more than one answer that would be correct because it doesn't have just one thing it's equal to. Okay, let's do the next one. 12 minus V is less than or equal to. I'm going to write less than or equal to. I think that you should write that so you remember what you need to have. Okay, so our answers have to be less than or equal to 4.5 to be correct. Okay, 12 minus 5.5. All right, I'm going to write this as this. Okay, that becomes a 1. 10, 5, 11 minus 5, 6.5. 6.5 is not less than or equal to 4.5, so this is not an answer. Let's do 12 minus 6.5. The reason I added a 0 behind 12 is to have my decimal points lined up because we need that when we're subtracting decimals. 0 minus 5 can't do that. This becomes a 1. This becomes 10. 5, 11, 5.5. 5.5 is greater than 4.5, so this is not an answer either. Let's do 12 minus 3.5. I'm going to line this up. 12.0 minus 3.5. Borrow. That is 11 minus 3 is 8.5. 8.5 is greater than, so this is not an answer either. And let's do the last one. So 12.0, I'm adding that 0 in, minus 2.5. Borrowing here, 5, 1, 11 minus 2, 9.5. This also wouldn't work. So for this answer, there are no solutions available. Sometimes you might have that. All right, next one. Mr. Wilson announced that no more than 350 students can go on the field trip. Which inequality expresses how many students can go on the field trip? So there are 350 spots. Can there be 350 students? Yep, there can be. We can have up to 350. Can we have any more? No. You can't have any more. Can you have less? Yes. All right, so let's read through this. S equals students, represents students that can go on the field trip. So S is greater than or equal to 350. Can more than 350 students go on the trip? No. This one is not correct. S is less than or equal to 350. So less than or equal to, that means it can be equals, S can be equal to the number 350, or S can be less than 350. Is that possible? Yes, but let's keep going because that's what mathematicians do. S is greater than 350. Can more than 350 students go? No. Cross it out. S is less than 350. Can less than 350 students go? Yes, but the best answer would say up to 350. So we can have exactly 350 students, or we can have less than 350 students. This one just says less than 350, so it's not completely true. So the answer would be B. All right.